Good evening students, welcome to basic electrical lectures. So in this lecture we are going to learn the significance of back EMF. So it is class number 9. In class number 8, before watching this back EMF, this topic, you should watch the working principle of DC motor. That is explained in the previous lecture, class number 8. See, however, in order to understand the significance of back EMF, once again I will revise the working principle of DC motor. But in exam, you don't write all this diagram. Okay, don't write this entire diagram. So I written this only to convey the concept of back EMF. Okay, got it? So let's consider this is a DC motor. So this outer part is called yoke and the poles are fitted to the yoke. These poles are fitted to the yoke. And this inside circle what I written, so this we can call it as armature of DC motor. See now, here black mark I written, this is called brushes, and inside I written this green circle with black lines. That is nothing but commutator with segments. Okay. See now, and this round markings what I written here, these are called conductors. Okay. So you connect the conductor to the segments. It is connected to the commutator segments. Okay. So each and every conductor you connect to one segment. Okay. Similarly, you connect this side. It is connected to each and every segment. So this, say this one line is called, this is called segment. So we can call this as segments. So like this, n number of segments, commutator segments. You connect each and every conductor to this commutator segments. See now, what do you mean by a motor? Motor converts electrical to mechanical. Without electrical input, we won't get a motor in action. See now, north and south pole. This is called main poles. Main poles. So I can write the lines of flux with dotted lines. I will write. So let me write with black color itself. So what I written this dotted lines is called lines of flux. Okay, or main flux. Or main flux. So from north pole to south pole, there will be a lines of flux. So let me write the direction like this. So the flux is moving from north pole to south pole, means that is externally. So while moving, this armature conductor going to cut the flux. So this will be the main flux. Now I am placing the conductor in the magnetic field. Okay, but these conductors are not carrying any current. Under that condition, you won't get interaction of the two fluxes. See now what I am doing, I am giving supply to these conductors. Okay. So now this brushes is there now. You connect these brushes to the external supply. Okay, that is DC supply. Okay, plus and minus. You apply some DC voltage. So let me write this as DC supply voltage. DC supply voltage, some voltage V. So whenever this voltage applied to this brushes, okay, see this brushes will not rotate. It is having just contact with the segments. So the brush will just contact with the segment. So whenever this voltage is applied here, so that voltage and all these conductors are connected in series. So that this voltage will going to drive current in this entire armature conductors. So now whenever current flowing through this, whenever current flows, so due to this applied voltage and all these conductors are internally connected in series, and the conductor ends is connected to the commutator segments. The segments will receive supply from the brushes. Once the segment receives current from the supply from the brushes, and that segment is connected to the conductors. So the current starts flowing in this. So whenever the current flows through the conductor, then what happens? This armature conductor going to create its own magnetic field. That is called, now what I done, I place the current carrying conductor in this magnetic field. Okay, got it? So now once I place the magnetic field, once I place the current carrying conductor in the magnetic field, so on left of the conductors and right of the conductors, so left of the segments will become dot. So the direction of this is determined by right hand thumb rule. Okay, and other side I will write cross. Okay, so now, so due to this interaction, whenever the armature conductor carries current from the external source, it produces its own magnetic field. That magnetic field interact with this main flux. So due to interaction of those two fluxes, it experiences a mechanical force. So on the north pole, the force is experienced like this. Okay, let me say it is F1. Means all this armature conductor is pushing upwards. Okay, or whatever the conductor comes under north pole, it is trying to move upwards. And similarly, this side also force is experienced, and that force will going to act in this direction. So if this, whatever the conductor comes under north pole, pushing upwards, so the armature cause to rotate. Okay, and at south pole, the force is acting like this. So this process will be cumulative. This process will take place as long as this brushes is connected to the supply voltage. Okay, got it? So likewise, the armature going to rotate when force is experienced. How this F1 and F2 is produced? Due to interaction of main flux and magnetic field around the current carrying conductor. Okay, got it? So whenever the armature conductor rotates, till here is called motoring action. Now whenever this armature conductor rotates, this armature conductors going to cut the main flux. Once this armature conductor cut this main flux, then EMF will be induced according to due to generating action. That induced EMF, okay, that induced EMF is called back EMF. Understood? So why it is called back EMF means whatever the voltage produced in the armature, so that voltage opposes the applied voltage according to Lenz's law. So it is called back EMF. Okay, got it, guys? So what is the point you should write is, so due to motoring action, so don't write all this diagram. Straight away explain the significance of back EMF. You start writing what is the point I am going to say. Okay. Due to motoring action, the armature conductors will going to rotate, and these armature conductors cuts the main flux, and hence EMF will be induced due to generating action. This induced EMF opposes the supply voltage, and this EMF is called back EMF or counter EMF. This point you should write it here. Okay, if I start writing, so video timings will be increased. Got it, guys? I will tell once again or replay again and again, so that till the completion of the sentence you can replay it. Okay, but I will tell once again. Due to motoring action, the armature conductor rotates, and these conductors going to cut the main flux, and hence EMF will be induced due to generating action in a motor. That induced EMF opposes the applied voltage or supply voltage. This EMF is also called back EMF. Okay, got it? Back EMF or counter EMF. So So red is not working. So I will write another word. Back EMF is also called counter EMF. Back EMF is also called counter EMF. Okay. So that is one point. Second point, back EMF is produced due to what? Due to generating action in a motor. So therefore, the EMF equation of generator is considered same equation for motor also. But we are using notation EB. Okay, EB is nothing but back EMF. What is the equation for this? Same as EMF equation of DC generator. So that will be pi p nz by 60A. So this is back EMF equation. So what is the point I said that you should compulsory write. So now I will start significance of back EMF. Now significance of back EMF. So first point you write. First point I won't write there. Write first point. It acts like a voltage regulating machine. Okay. So voltage regulating machine. So the significance of back EMF is voltage regulating machine. So it acts like a voltage regulator. Okay. So second point, what I am saying, it is again similar to the first point. Okay. Any one you can write in exam. So that is back EMF is also called self-regulating machine. Self-regulating machine. So out of 1 and 2 you write any one. Okay. Next one is point number 3. You should write it automatically alters the armature current to meet the load torque requirement. Okay, got it? So I will write it. So it automatically alters the armature current, armature current. It automatically alters the armature current to meet the load torque requirement or load requirement. To meet the load torque requirement. To meet the load torque requirement, so the back EMF will going to take place. This EB, this back EMF will going to alters the armature current to meet the load torque requirement. That is point number 3. Next point number 4. Back EMF is directly proportional to speed. Back EMF is directly proportional to speed. See, if the armature conductor does not rotate, therefore this conductor will not cut the main flux if it doesn't rotate. So when the speed is 0, what is the back EMF? 0. If the armature runs, if the speed increases, back EMF also going to increase. So if speed is 0, then back EMF is also 0. So when back EMF is 0, that indicates there is no interaction of the two fluxes. Okay. So that is the main flux and the conductor flux will not interact at all. If it doesn't interact, force is not generated. Okay. If there is no force, then armature won't rotate. If this armature doesn't rotate, then it won't cut the flux and hence back EMF will not be produced. So we can say the back EMF is directly proportional to the speed. Okay, got it? So in all this equation, so the flux is constant. Once the machine is designed, we cannot change the value of flux to meet our requirement. So the number of poles is fixed. In order to get sufficient back EMF, you cannot increase or decrease number of poles directly. Okay, once the machine is constructed. So number of conductors, this 60, and number of parallel path we cannot change. So speed we can modify, speed and the flux. See, flux also we can monitor externally. Okay, got it? See now, in sometimes, see the main flux is there. Between north to south pole, there are main flux. Suppose if this flux is not required, not sufficient, under that condition, we can also excite this poles by connecting the field windings. Okay, look at here guys. So, I will take the, so let me write in black color. So, you can own the field windings. So, like this, and you can connect it like this. Then finally, you take it outside. So instead of writing there, we can write it this side. Okay, look at here guys. So this will be plus and minus. Then again you apply some other DC voltage. Okay, DC voltage. How much you are going to apply this voltage is just to get the required main flux. Okay, sometimes if I place only north and south pole magnets, it is having some amount of flux. That main flux is not at all sufficient to get better interaction. So if it is interaction is better, you will get a more force, then your armature speed will increases. So under that condition, externally we are connecting field windings, and those field windings are excited with the supply voltage. See, so if I apply voltage, current starts flowing. So that current will circulate in this field conductors. Okay, see the current flows like this. Again it is coming like this. Again it goes and again it comes down. Okay, and again it goes like this and it comes back. So like this. Okay, what happened if I pass voltage to this field windings? It produces again more flux. Therefore, the total main flux is increases. If main flux is increases and you apply supply voltage to the brushes, current flows. Okay, that current will produce magnetic field. Again, interaction takes place. Force is exerted. Okay, on one the conductor comes under one north pole will be dot, and conductor comes under south pole will be cross. Okay, if we interchange this supply voltage, so this all will become cross and this will become dot. Then the direction changes. Okay, got it guys? So what you should write in exam is, okay, only this point. Okay, sorry for that disturbance. So I am holding 3 pens while exchanging one drop now. Okay, only this part you write for exam. This is the significance. See, this 3 points is more than sufficient to get 5 marks. Okay, now I'm giving now practical reason how it going to automatically alters the armature current. So for that one equation is there that you should write it in exam. So understood guys? So instead of writing all the diagrams, I explained in a construction diagram by taking the construction diagram. So now I hope everyone understood the again working principle of DC motor and also the significance of back EMF. Okay, so now I will give reasons why it is called voltage regulator and why it is called how it going to automatically alters the armature current. All the reasons I am giving now. So for that you should write equivalent circuit of DC motor. Okay, equivalent circuit of DC motor. Okay, very important. See now, first I will write a symbolic representation. So what do you mean by motor? It receives electrical and produces mechanical. Okay. So first let me write equivalent circuit of symbolic representation. So this is a machine. Okay, machine. So brushes will be here. Okay. So what I am doing is I'm connecting this entire armature to the supply voltage. To the supply voltage, plus and minus DC supply. See now, whenever the machine is connected to supply, then what happens? It receives current. So this current is called line current. Okay, in generator, IL is called load current. In motor, IL is called supply current or line current. So that current flows through the armature. So it is having armature resistance, and in the motor, back EMF is generated. Okay, got it? So this is what symbolic representation. Now equivalent circuit is nothing but just I am replacing, okay, resistor and back EMF similar to the electrical circuit. So I will erase this. I will erase this one, and then I will write, okay, resistance will be there. This is what? Armature conductor resistance. And in motor, back EMF will be produced. Plus, minus, what is this? Back EMF. See, this is called equivalent circuit. Now apply KVL to this circuit. So shall I take clockwise direction or anti-clockwise direction? See, motor receives the supply. So this is the direction you take anti-clockwise. Okay. Apply KVL to this loop. See, whenever current enters, mark plus, leaves negative. Apply KVL for this loop. What happened? Minus to plus is rise. V plus 2 minus drop. Minus IA RA plus 2 minus drop minus EB is equal to 0. What it is? KVL equation. In any closed circuit, the algebraic sum of all the EMF sources and individual potential drop taken with proper sign convention would add up to 0. First model. Okay, now V is equal to, you take all negative to the right hand side. V is equal to EB plus IA RA. IA into RA. Now I am going to write from this I am going to write armature current equation. Look at here. So V minus EB is equal to what? IA into RA. So from this I can write armature current is equal to V minus EB divided by RA. V minus EB divided by RA. Okay, now see, numerator going to change voltage and armature resistance is fixed. Okay, and the value of armature resistance is very low. Let analyze at the moment of start. See, once you give supply to the brushes, immediately it won't run at certain speed. Okay, so interaction with the magnetic flux will take place. So till then, around up to 1 or 2 seconds, it takes some time. Immediately it won't run. So at the moment of start, the speed of the armature is 0. If the speed is 0, then back EMF is also 0. Okay. So then what happens? Your armature current will becomes what? IA is equal to V by RA. So what is this condition? At the start, at the moment of start, your back EMF will be 0 because no speed. See now, armature resistance is very less. Okay. So there will be some constant supply voltage around 220 volts. 220 volts by this resistance, you will get a large value of current. very high current. If I pass this current even for a fraction of a second, your armature conductors will become burnt because excess current flows. This current will be 10 to 15 times more than rated current of the armature windings. Okay, got it? So we should not pass this excess current. So this excess current can be limited by adding external resistance in series with the armature. So that external resistance will going to limit this current. Okay. So that way, in order to limit this current, we are using starters. Okay, 2-point starters, 3-point starters. Okay, starters nothing but it going to limit the starting current. Okay. So now this analysis will not comes under back EMF, significance of back EMF, but this current can be limited by using external resistance. Once it comes to safer value, then the armature runs. So when armature speed increases, okay, then what happens? Back EMF is also going to increase. So if back EMF increases, what happened now? The numerator, see, supply voltage is fixed, back EMF is increasing. So this resultant V minus EB will going to what? Decrease. Suppose if it is 220, if it speed increases, you may get this 100 volt. Okay, so 250 minus 100, 150 volts. See, numerator get reduced. So numerator part going to get decrease. So now for a fixed value of resistance, so if earlier it was having only exact voltage, supply voltage. Now back EMF is increasing when armature runs. Okay, so therefore what happens? Armature current going to decrease. Now again you apply some load. If you apply load on the motor, armature conductor, if you apply load on the armature speed decreases. If speed decreases, back EMF also decreases. So if EB decreases, again your armature current going to increases. So this armature current will going to alter automatically to meet the load torque requirement. Okay, what happens now? If speed decreases, torque of a machine increases. If torque increases, current also increases. Again, if speed increases, torque decreases, then current also decreases. See, this armature current will keep on altering automatically to meet the load torque requirement. So this armature current will take care, this back EMF will take care to operate the motor in a desirable and safer way. And final significance is back EMF will never become greater than supply voltage. Keep that in mind. So this is point number 4. Point number 5, you write like this. Okay, EB never becomes more than supply voltage. Okay, if EB should be lesser than supply voltage, then only it acts like a motor. Okay, if EB is more than supply voltage, then we become generator. But in a DC motor, it won't happen. Okay, got it? So guys, this what I explained, the significance of back EMF. Don't write. See, only to reach the concept. Okay, so I explained with the working principle. That and all you don't write. So start from here, first point. So what is this first point? Due to motoring action, the armature conductor rotates and that conductor cuts the main flux. And hence EMF will be induced due to generating action. This induced EMF opposes the supply voltage. So according to Lenz's law, okay, that EMF is also called back EMF and another name is also called counter EMF. So we have written that equation, later list out the points. Okay, got it guys? So guys, please give a like and share the lectures to all your P-cycle friends. Keep supporting like this so that we can upload the video lectures within a stipulated time. So 26th onwards exam going to be starts. So within that I try to finish or 5 modules. Okay, and remaining modules, some problems is left, that also I will do. So I need your continuous support from my subscribers. Okay, so take it as a responsibility to share the video lectures to all your known friends. Okay guys, take care, bye bye, have a nice day. In the next class I am going to derive torque equation of DC motor. Okay.